So it says following instructions for problems show all work. So the first one is we're going to write the following exponential form, and we know that it's going to be log. The base is 2.4. The answer is 1, and the exponent is 0. Okay. So we have number 2. You're going to write log. The base is 4. We know the answer is 8, and the exponent is 1.5. For number 3, we have log. By us not having a base here, it's be default. That's a common base. The answer, and it's equal to -2. For number 4, we have x to the power 2.5 is equal to 32. So what you do is you start by writing log. The base is x. We know the answer is 32, so that equals to 2.5. Number 5, we have 6 to the power x equals 216. So we have log, base of 6. The answer is 216. So the x will be the exponent, will be equal to x. And then number 6, we have log. The base is 25. The answer is 625. So the exponent is 2. Number 7, we have 1/2 raised to the -2 power is equal to 4. So you're going to write a log. The base is 1/2. The answer is 4. And it's raised to the -2 power. That's going to be the exponent. Number 8, we have 8 raised to the -2/3 is equal to 1/4. So once again, you know that the base is 8. You know the answer is 1/4. And you know the exponent is -2/3. Number 9, we have 1/3 raised to the 3rd power is equal to 1/27. So we're going to go ahead and write log. The base, once again, is a fraction. It seems kind of awkward, but it is a fraction. We know that the answer is 1/27, and that's equal to the exponent. For number 10 all the way to 18, we are going to write the exponential form of each of those logarithms. Remember that for each of them, we have a base. This number 10 is going to be 4. We have log base 4 of 0.0625 is equal to -2. So the exponent is -2. So you have 0.0625. Number 11, we have log base 3 of 1/9 is equal to -2. So we know that the base is 3. We notice the -2 is the exponent, and you have 1/9. Number 12, we have log of pi, base pi, of pi is equal to 1. Remember that pi raised to the 1st power is pi. This is a property, right? Number 13, we have log base 6 of x is equal to 3. We know that the base is 6. We know that the exponent is 3, and we know it's equal to x. Number 14, we have log base x of -16 is equal to 3. So we have x raised to the 3rd power is equal to -16. Number 15, we have log base 5 of 625 is equal to 4. So we know that the base is 5, the exponent is 4, and it's equal to 625. And 16, we have log base 2 of 128 is equal to 7. So you have 2 as the base, 7 as the exponent, and 2 to the 7th is 128. Number 17, we have log base 3 of 6,561 is equal to 8. So if you type this into the calculator, 3 to the 8th will give you 6,561. And number 18, we have log base 4 of 64 is equal to 3. So the base is 4, the exponent is 3, and that's equal to 64. So we're going to use the following x values to graph each function, then graph its inverse, write the inverse of the log function. So you have 5 raised to the x power, and when x is negative 2, we have 0.04. When x is negative 1, it's 0.2. When x is 0, it's 1. When x is 1, it's 5. And when x is 1.5, what you're going to get is, and I have to go to the calculator so I can do this, 5 raised to the power 1.5. And we get 11.1, in this case 1.2. And I'm going to go ahead and graph this. So we have negative 2.04. Of course, you can't physically graph that. It's pretty hard. Negative 1.2. I have 0, 1, 1, 5. And then you have 1.5. And it kind of grows pretty rapidly. So there is my function. Y is equal to, f of x is equal to 5 to the power x. Now, to find the inverse, you're going to go ahead and basically write the y column here on the x, since you're switching the x and the y. And then you have negative 2, negative 1, 0, 5 is 1, 11.2 is 1.5. So what I'm going to do is 10, 11.1 is 1.5, so I know it's going to be somewhere here. 5, 5, 1, so it's right here. 1, 0 is right here, so you know that the graph is going to look something like this. Okay? And we know that the inverse is going to be log, since we've been talking about, and we know the base is 5 of x. Okay? And what you're going to do is you're going to draw the mirror. Remember, the inverse will always have this y equals x as a mirror. And there's my graph. Here, this graph, we have y equals 5 to the power x. And this graph is going to be y is equal to the log base 5 of x. It's the inverse. Okay, we're going to be graphing f of x equals 1/2 to the power x. And what I'm going to do is I'm going to go ahead and graph that on my calculator. Y equals parentheses 0.5, which is the same thing as 1/2 to the power x. And I know that when x is negative 2, it's 4. So I'm going to go ahead and write that. We have 4. When x is negative 1, it's 2. X is 0 is 1. When x is 1, it's 0.5. And then it's 0.25 when x is 2. So let me go ahead and graph that. Negative 2, 4. Negative 1, 2. 0, 1. 1.5. And then 2.5. So it's going to look something like this. So now we're going to go ahead and graph the inverse. So remember, in the inverse, you're switching the x and y axis. So you have 4, 2, 1, 0.5, 0.25, and then we have negative 2, negative 1, 0, 1, 2. And we know that it's going to be log, and the base is 1/2, and it's going to be x. So let me go ahead and graph that. So we have 4, negative 2, 2, negative 1, 1, 0, oh, it's right here, 1, 0. That was my mistake. 0.5, and then 0.4 is 2. So it looks something like this. And there's my inverse function. So we have log, and the base is 1/2 of x.